Hi guys! Welcome to another Solve Reactions with Me video. As you see, we have here a scheme with multiple reactions and gaps that we need to fill in. Let's start from the first reaction in the scheme. Here we have magnesium as a reagent, and as a product we have a Grignard reagent. So as you might expect, on the right side we have basically just different variations of the Grignard reaction, but we will come to this later. First of all, we need to produce a Grignard reagent, and this can be done by mixing magnesium with the corresponding alkyl halide. In our case, it is ethyl bromide. In this reaction, magnesium inserts itself between the carbon and the bromine. For the reaction mechanism, you can check out my another video where I am explaining in detail the mechanism for the same reaction with another alkyl halide. Okay, so we produced a Grignard reagent, and now we must predict the product of its reaction with formaldehyde. In general, Grignard reagents act as nucleophiles because of a partial negative charge on the carbon. And as a nucleophile, a Grignard reagent can attack any imaginable electrophile. In this case, we have an aldehyde as an electrophile with its partially positively charged carbon in the middle. So next, a classic nucleophilic addition on a carbonyl group happens. Double bond breaks. Oxygen is left only with one bond, and a negative charge is neutralized by magnesium bromide coming from the Grignard reagent. The remaining part of the Grignard reagent, the alkyl group, makes a new bond with a central carbon atom. Now it is important to understand that this is not your final product that is expected from you in the exam. Even though it was not explicitly mentioned that you need to add water afterwards, it is kinda expected from you because you need to understand that the relevance of Grignard reactions is not just to get this random molecule with magnesium, but to produce another class of organic compounds. When you use a Grignard reaction on aldehydes or ketones, the final goal is actually to get an alcohol from it. When we add water, the negatively charged oxygen takes away the partially positively charged proton from the water molecule, and our compound is converted into an alcohol. And as a byproduct, hydroxymagnesium bromide is formed. Now let's fill in the gap in the scheme. Here's our final alcohol molecule. And to summarize the reaction in a very simple way, we just merged the aldehyde with the alkyl group, and the aldehyde group itself was converted into an alcohol group. Since the final alcohol molecule has 3 carbon atoms in total, and the alcohol atom on the first of them, the name of this compound is 1-propanol. Or to be absolutely correct, it is propan-1-ol, according to the IUPAC nomenclature rules. In the next reaction, we have again a Grignard reaction with a carbonyl compound, and we already know that the final product will be an alcohol, but here we see 2 gaps. Why are there suddenly 2 products even though we had just one in the previous step? In this case, we need to take a closer look on the reaction mechanism again. Just like in the previous case, Grignard reagent acts as a nucleophile, and a nucleophilic addition on the keto group happens. The partially negatively charged carbon attacks the partially positively charged carbon of the carbonyl group, double bond breaks, and the oxygen gets negatively charged. I will mark the new coming ethyl group in red, so it is easier to see this part in the product. And let's mark the carbonyl group with a black dot. It is now directly connected with the new ethyl group. Before addition, we also had a methyl group on the central carbon, and now let's show its position in 3 dimensions. Our ketone was planar before addition, but now the central carbon has only single bonds around it, so it has an sp3 hybridization, and in 3 dimensions it will have a tetrahedral geometry. Therefore, one group will be facing to the front and one to the back, so to say. And since Grignard reagent can attack the ketone from the front or from the back side with the same probability, we get 2 enantiomeric products. So after hydrolysis, we get also 2 enantiomeric alcohols. The main chain contains 6 carbon atoms. The methyl and hydroxy group are both at the 3rd carbon, so the final name for both compounds is 3-methyl-hexane-3-ol. The difference between 2 molecules is only the configuration, so let's determine it. Let's number all the substituents around the chiral carbon atom with 1 corresponding to the heaviest atom or residue attached, 2 the second heaviest, and so on. Now the rotation happens from the number 1 to number 3. So this molecule has an S configuration. The other molecule is just an enantiomer, so it should have exactly the opposite configuration. And as you see, it is indeed the case. It is an R compound. Let's fill in the gaps in the scheme. And as you see, there is only one reaction left unsolved. CO2 also has an electrophilic central carbon atom that can be attacked by a nucleophilic Grignard reagent. As always, double bond breaks. Ethyl residue is now directly connected to the central carbon. We get an intermediate magnesium bromide bound product that can be further hydrolyzed. As always, the negatively charged oxygen takes the hydrogen atom from the water molecule. So as a final main product, we got here a carboxylic acid, and magnesium hydroxybromide is our byproduct. Let's fill in the last gap in the scheme and name the final product. This acid has 3 carbons, so it is a propionic acid. Okay guys, that's it for today. I hope this video was helpful for you. Let me know in the comments below if you have any questions or if you have any reactions on your mind that you want to solve with me next time. See you in the next video. Bye!